Power tells us how fast energy is being transferred in a circuit. The instantaneous power is P of t equals V of t times I of t. Voltage is in volts, current is in amperes, and their product gives us power in watts. 1 watt equals 1 joule per second. If the power is positive, the element is absorbing energy. If negative, the element is delivering energy to the rest of the circuit. Energy is the total work done over time. We find it by integrating power. W equals the integral of P of t dt from 0 to infinity, which is also the integral of V of t times I of t dt. Let's work through an example. Suppose the power is P of t equals 200,000 times e to the negative 10,000 t in watts. To find the total energy, we integrate from 0 to infinity. Using the hint that the integral of e to the ax dx equals e to the ax divided by a, we get 200,000 divided by negative 10,000 times e to the negative 10,000 t, evaluated from 0 to infinity. At infinity, the exponential goes to 0. At 0, e to the 0 is 1. So W equals negative 20 times the quantity 0 minus 1, which gives us W equals 20 joules. The element absorbed 20 joules of energy total. How do we know if an element absorbs or delivers power? This is where the passive sign convention comes in. Here's the rule. If current enters through the positive terminal, then P equals plus I times V, and the positive result means the element absorbs power. If current enters through the negative terminal, or equivalently, if the current direction opposes the voltage polarity, then a positive P means the element delivers power. The sign of P tells you everything. Positive P with passive sign convention means absorbing. Negative P means delivering. Example 1. We have a circuit element with a current of negative 3 amperes and a voltage of 2 volts with the positive terminal on top. The current arrow points into the positive terminal, so we use P equals I times V. P equals negative 3 times 2, which gives us negative 6 watts. The negative sign tells us this element is absorbing 6 watts of power. Wait, negative means absorbing? Yes, because the current is already negative, meaning it actually flows out of the positive terminal. So effectively, the element receives power. Example 2. The current is negative 3 amperes. Voltage is negative 2 volts, with positive terminal on top. P equals negative 3 times negative 2, which equals positive 6 watts. But here, the current enters the negative terminal, so positive power means this element is delivering 6 watts. Example 3. Current is negative 5 amperes, voltage is 6 volts. P equals negative 5 times 6, which gives us negative 30 watts. The current enters the positive terminal. With passive sign convention, negative P means delivering. This element delivers 30 watts to the circuit. Example 4. Current is negative 6 amperes. Voltage is 10 volts. P equals negative 6 times 10 equals negative 60 watts. The current enters the positive terminal. Negative P means delivering. This element delivers 60 watts of power. Notice the pattern. Always check which terminal the current enters. Then apply the sign convention consistently. Let's review. Power is P equals V times I, measured in watts. Energy is the integral of power over time in joules. The passive sign convention tells us if current enters the positive terminal, positive P means absorbing, negative P means delivering. Always check the current direction relative to the voltage polarity before calculating power. In the next video, we'll start applying Kirchhoff's laws to analyze complete circuits.